Hello everyone, welcome to the EasyPower Refresher webinar series. My name is Jim Chastain. Our topic today is best practices for modeling and coordinating loads in motor control centers. Along the way I'm going to be comparing the utilization of an MCC icon versus discrete load bus descriptions on your one line. And hopefully explaining the advantages, pros and cons for your particular use. And as we're in the habit of doing, we'd like to start with a poll question, so I appreciate everybody's attempt to be responsive. First question is, how often do you use MCC schedules versus discrete motor loads on your projects? No right or wrong answer, strictly just your own perspective on the topic. No obligation one way or the other, just strictly trying to get a feel for where people stand on this. We spend a lot of time, I think, describing the discrete modeling capabilities, and we don't as often use the MCC schedules, at least in the webinars. So hopefully we'll be able to share that. So we're close to a quorum. Let's give this another 5 seconds for people to respond. Okay. Here's how people weighed in on that. So less than 50% of the time. So fine. The next question is, what drives that decision? Again, no right or wrong answer, strictly your own particular situation and perspective. All attendees for today's session will receive a certificate of attendance via email. You don't have to do anything. Usually takes us 3 or 4 days to get those out. So don't be surprised. Sometimes they show up in your spam folder, so don't be surprised if it's the end of the week before you hear from us. Okay, we're close. Let's give this another 10 seconds. Thank you for participating. Here's how people weighed in on this. Excellent. So it looks like a majority prefer to use discrete loads on one line. Excellent. And finally, how often do you generate an elevation view of the motor control center? This has nothing to do with best techniques. It's strictly just a curious point where I'm not sure how often you're required to do an MCC schedule. Now, I don't want to forget about this, but there's 2 primary differences between these 2 methodologies, and they involve a slight customization, and I will be covering the details on that at the tail end, so stay awake. All right, looks like we have a quorum here. Interesting that elevation view is only utilized 50% of the time. Thank you very much. Okay, let's jump into the details here. So as I mentioned, what I'm going to be doing is comparing the differences between the bus orientation and the schedule implementation of motor control centers. And as you kind of point out, the individual loads give you better visibility on the one line. It allows individual correction factors. Although you can do it in an MCC schedule, it's a little bit more buried, if you will. You can create a separate arc flash label for individual loads which you cannot do with an MCC schedule. And you can generate an abbreviated schedule from the discrete implementation. So that's one of the things I'm going to want to go through here shortly. And then it makes it easier to tune the individual loads if you're trying to utilize your model for simulations of your actual system, and you want it to be as accurate as possible. So let me just kind of touch on these, and then we'll get to the schedule part of it. In fact, what I'm doing, you'll see this. I want to create this representation in the form of an MCC schedule. And just because I'm on the topic, oh, by the way, questions are welcome at any time, so use the question entry block in the webinar control panel. Once I've built the discrete representation of my MCC, I can go in and in the, not the switch, but the bus description itself, I can describe, and I want to make sure I put in the rating and the bracing for the motor control center. I want to include any comments. First of all, in this case, we've included the main fuse in a separate enclosure. They call it sequestering. So I want to comment that so I can include the main in my calculations for arc flash. And then I have the ability to create a schedule. If I go back to I can create a schedule from the switchgear tab, enable the calculations of the bus. I want to make sure I've designated which cable or input feature is my main. And once I've done that, and these can be designated as feeders, ties, or mains, then I would calculate the downstream load. All this is fed into a modified schedule. If I want to generate a elevation, I can put that here. Much as I do in the TCC, MCC icon methodology. But once I do that, then I can have a representation of my elevation. So, excuse me. So this can be generated and utilized for a schedule. And the one thing I can do that I can on the MCC schedule for the icon is include arc flash results. So if I want to include a schedule on this for this bus, so I'm assuming everyone that does discrete modeling is aware, or at least should be aware of all these properties. Just as an aside, my coordination efforts are going to be centered around the largest load on this MCC bus. And it's a good exercise that you should exercise for yourself, prove to yourself that once I've coordinated for the largest load, then the smaller loads by default are going to be coordinated. But in this case, I'm going to coordinate for this largest load, go into coordination, plot the TCC, and what we see are the results of the setup for that particular transformer, motor, cables, and then my breaker with the overload included. So at this point, I'm thinking everybody that uses discrete loads can. So VJ is saying, how can we update the feeder numbers in the MCC schedule? That's a good point. Let's see if I can do it. I'm assuming that you're talking about the discrete implementation. So if I want to add another load or let's just add a motor, I have to do it in the database edit. Let's save my changes, put a motor in here. Open up the schedule, and that shows up on the schedule. Now, you say, how do I rearrange these? I'd have to play with it. I would start from scratch. So I don't know if that answers your question or not, but that's how you add. Well, I take that back. So I've added M7. I don't think it matters where I put it. Real-time question answers. Yeah, no, it's going to add it at the end of the list. Okay, so that's a discrete implementation. And the difference and the significance is as far as arc flash, when I calculate arc flash values, I'll get a result for every load in addition to the main bus. Now, when we start looking at a comparison, I'm going to take this load off. Of how an MCC schedule would work, we put the icon on the one line, determine what the incoming situation is. In this case, we're going to have a main fuse, tie it to the main branch, and then anything that's going to be displayed on a TCC curve has to have more complete information than is allowed on the schedule. So I'm going to use the incoming device selection to put in the same information in the same way that I did when I have a discrete element. So now I got the main fuse set up. I'm going to put a comment in there that the fuse is in a separate box. It's sequestered, so I can use it to include in the main. If I look at my description of the elements, I just right-click and pick out the load type. In this case, we're going to try to replicate our one line over here. So I have a linear motor. The large motor is going to have a TCC plot with it. And then the motor on the right will be the smaller one, the 50 horsepower. Now this schedule, or the MCC representation, it's a very extensive list of columns. They're all there. I can organize this to not put in everything or not show everything by going to configure, and then whatever I have checked here will show up in this particular report or this schedule. So for now, I'm just going to hunt and peck until I find what I want. Once I've got the motor specifications, the tool will calculate the full load rating just like it would in a discrete part. So we're going to plot a TCC based on the fact. So the question from Greg was, Craig, can you still plot a TCC plot? The answer is yes. So it'll plot any load that I have included a TCC with this indication. And that's why you only want to do the largest load. Once I've selected that, when I go to the motor specification for the other loads, we put in the horsepower for that particular load. For the one with the TCC, it'll gray this out, and I have to enter the data with this data button here on the right. And from here, we'll put in the load calculations for the motor that's going to have the TCC plotted with it. And if we need to make any modifications, either in the starting current or the X over R calculations, we do them on this particular entry. Does that make sense? So once we've got the TCC data input, likewise for the cable is going to be on the TCC curve, so we need to input the cable information via this little icon, which will be highlighted in red. This is the breaker first. We enter the information for the breaker with a TCC plot, just like we would standalone breaker. Breaker information, we want to make sure it's in the device library under short circuit, auto calculate. Then when we go to motor overload, we want to plot it and use the same information that we used if we were doing this discretely. So now that I've done that, I need to put in the information for the cable. Again, this is going to be stuff that's detailed specifically, whereas the other parts that aren't going to be on the TCC curve, I can just enter the information like I would. And that's another thing. Some of these columns are narrow. I can make them wider or scrunch them down based upon what I'm trying to illustrate or access the information on. But the point is, on the TCC curve, I need to use the data block or the data entry, which is going to be highlighted. And now we put in specifics for that cable, auto-calculate it, click OK. Any questions on that? So there's a lot of data, and the more accurate and the more complete you fill these columns in, the closer the comparison will be. Once we're through populating all of the spreadsheet for the loads, we go to summary and we calculate the downstream load. This will update any sub panels or sub loads that we have. And then based upon that, we go to short circuit and calculate the X over R. So it needs to have, this is mandatory data, and it won't be filled in until I click calculate. Now with that done, we should be able to go back. Now, let's go ahead and compare the transformer and the MCC curve. Go to coordination. So now what we see on the TCC plot, just like we saw on the discrete, we see the motor starting curve, we see the MCC breaker. This is the main fuse. Here's the row 1 cable. Here's our thermal overload plotted, and here's our transformer. It looks very similar to what we had when we had a discrete implementation. Any questions on that? Now, how do you know if you got them close enough? The clearest, let me take that back. The biggest difference is the ability to save loads, bus count, by using an MCC schedule versus a discrete load representation of the motor control center. And at 3 or 4 loads, there's not much difference in total bus count. But if you have 20 or 30 loads in a motor control center, clearly the schedule is going to be different as far as the load count in my buses, and you'll only eat up 1 or 2 buses for a 30 load MCC. Okay, so any questions of what we've done so far? We've basically shown how to model using the same data that we would on a discrete implementation by utilizing the MCC icon itself. Now, once we have an MCC there, I can right-click. I need to go back to Database Edit. I can right-click and show the schedule. Now these schedules have templates, and the templates can be modified. And one of the popular features that is requested frequently is, what if I want to include the worst case fault current and the arc flash results, which are calculated for the main bus and the MCC. Well, to do that, I go to my properties for the project. I pick out the MCC schedule, not using the standard one, but I pick out the one that I've modified for arc flash. And by doing this, it's going to change the display on all the MCC schedules. So now from the template, we show a slot for short circuit current, arc flash boundary, working distance, and instant energy. And once we've got the template going, now we can go back to short circuit. And instead of just fault the bus, we want to do an advanced fault the buses and store. So we're going to fault and store the fault current, and that fault current now will be entered in my spreadsheet. If we go back to fault the buses advanced arc flash, it'll include the arc flash boundary, the working distance, and the instant energy. So this template is an HTML modification for the template that's there. Be happy to send a copy to anybody that wants to email me for that information. Okay, now, for what it's worth, this template is also modifiable. I just haven't done it, but it could be done very similarly for those of you that are inclined to make adjustments to the template. Okay, so what we're trying to show, now this is where I wanted to be. So right now, based upon my initial trial, I'm showing a model in my of 18,745 short circuit current during the first half cycle coming from the transformer, and I show a 1 amp difference coming from the transformer in my MCC schedule. I show fault current, available fault current on the main bus of 21,666. I see a 30 amp difference. No, it needs 300 amp difference between the total available fault current in the icon versus the discrete. Now, if I were careful and I wanted to look into this more, I'd take some steps to find out where that difference comes from. If I compare the time slice between half cycle and 30 cycle, I see all my loads tabulate to 18,656, which is exactly what I have over here. So I have some difference in the way I've implemented the motors, or the way they're represented here, compared to what's going on inside the motor control center. So for those purposes, I take some time to analyze or to understand. It's probably going to be in my impedances. Frank's asking, what MCC dimensions should be used for the arc flash calculations, bucket, column, overall? The way the IEEE 1584 calculations are made is the dimensions are the enclosure of the breaker itself. So if things are in a separate bucket, the dimensions for arc flash would be the bucket itself. So let's see how that looks. If I go into my arc flash hazard tab, the defaults for the individual buckets. So I answered my own question. Because we're not doing an individual load calculation, this is strictly on the main bus itself. And so when I'm including the main, this is because it's sequestered. The enclosure doesn't have anything to do with the calculations for the bus. Enclosure for the box itself. Does that make sense? So the answer is I don't care what the buckets are for the individual breakers, because I'm not calculating arc flash for the load. I'm just calculating for the main bus and the motor control center itself. Hope that helped in this case. Okay, so one other thing I wanted to show, and again, by all means, come at me with more questions. We've shown the ability to do arc flash and short circuit current in the schedule. There's one other feature that's available in the motor control center icon implementation that can be an advantage if you do a lot of population of motor controls. And it's called library load. So this takes modifications in your device library. So let me kind of walk through this. What it amounts to, if I go and look at my library, I have created and saved typical populations for several different types of loads in my, and saved that in my MCC schedules. So I've created a spreadsheet. Looks something like this. I did one so I calculate these on a standalone basis. And for a 100 horsepower motor, these are the results that I expect to load into the motor control center data block once I've selected that particular load. The thing that may be different as I use this table is the length of cable. So I want to be mindful of that. So anyway, what I've done is I've created a spreadsheet. In this case, I have one for 480 volt systems and one for square D systems, and it makes a difference on what I populate. Now, once I've created these schedules and saved them in my device library, and it takes a little bit of practice, frankly, to get it right. But now I don't have to enter all that data in my summary, my description. All I have to do is add a row to this bottom of the list. And now for my library load, I'm going to go up and say, okay, I need to go to that special list, and I want to pick out from my square D spreadsheet, library load for 100 horsepower. And as I do that, now all that data gets populated in that row in the spreadsheet. So this is what I came in from that spreadsheet. And so I want to populate the length. So let's say it's 35 feet. And now if I want to, well, I can put in as many loads as I want. And then as a result, do a summary update, recalculate the short circuit X over R, and I'm ready to go forward. So if I had a lot of loads, if I had 20 or 30 loads and they're all the same manufacturer, and I can use data that I know is going to be common to every specific size of motor, I can just pull it all in from the library load and save time by the bucket. Let's see if we got another question. Okay, so library load is different. The schedule update is different. And it just takes some modifications to your device library, but if you do a lot of motor control centers, it could save a host of time. I think that's what I wanted to cover today. For the most part, it specifically depends on your particular needs or desire to see the details on the one line versus have a cleaned up one line and use fewer buses. So by all means, if you want a copy of that hard flash calculations for the inclusion in the schedule, let me know. Appreciate your attendance today and look forward to talking to you down the road.